You all know why. But we appreciate the opportunity. You're going to see some work in progress. Okay, and the purpose of this, when I first touched base with Amitabh, was, hey, Amitabh, we need to go through a round of feedback to help us continue refining our job, our work, as opposed to this is the final presentation about this thing. Okay? So I understand the purposes of the task force, which are right on with what we are up to doing, but and I believe this will contribute some material to it. Now, it would be fantastic if through your feedback you contribute to our job too. Okay? So it's a two-way street, please. Ben has seen this, so if he snores too high and loud, don't take it too bad because he's seen most of it. We did morph a few slides because of his comments. And same thing with Jim Laris. He has also seen them and morphed a few others because of his comments. And I expect to morph some of these because of your comments. Okay? You're going to see some 30 minutes of introduction of problems that we see are new, okay, and changing environment. And the reaction we've consistently been getting is like, oh my God, you're just putting so many problems and no priorities, and why don't you just give me the bottom line of which is more important, right? And Marvin and I are like holding back our opinion on that until we gather more evidence and more opinion from these smaller groups and from some customer visits, okay? So far, the first 30-40 minutes you're going to see lots of areas being put in front of you. Then you're going to see some suggestions that we have, and this is an unbelievable arrogant exercise, right? Like here we come, Marvin and I, absolutely non-experts in this thing, and we're going to just tell you some stuff. Well, we've tried to narrow some areas that we think if we miss bad, that we should not miss. And we haven't refined them to the point of here is this project that hits exactly this area, but you see the areas and they insinuate themselves pretty nicely, okay? And the third part is a two-slide part where we have some questions. Questions that we think that if they get answered may help us decide, oops, we are looking at the wrong point of view. We need to change this point of view, or, oh, I haven't thought about that. Okay? So we don't expect you to answer them right here unless you fall asleep, in which case we will. That's kind of, the carrot and the stick. But it would be nice if you think about them, you tell us what you think about them. And also you may want to tell us this is not the right question. This other question is a much better question to be asked. Okay? I've been full-time doing this broad study since pretty much I joined MSR in early February. Marvin has been with me since the outset and has been a progressive amount of units of time of his day. He still split a little bit, between other projects and this project. That's how we work. And the output of this, in addition to the final version of these talks, will be a white paper. And I also have some background material that we are gathering. We've been visiting websites, we've been reading parts of the literature, we've been doing customer visits, we've been attending conferences, some at fabulous places, some at some at nondescript places as well. And we are trying to just pull this knowledge together so that we find some areas and projects that we can fit right on with the development strategy. The outline of the talk, I've given it to you already, but it's basically, I'm going to show you the way we think about the internet. It currently says 2 views of the internet, and it will, in the final version, say 3 views of the internet. Okay? There's a third view that it's absent. Let's not get into there because it will distract us. But at some point, if you see us give this at the MSR level, you will have a few views of how they are very good. Okay? So I'll show you what my 2 views are, and they are defined in page 3, in slide 3. And one of them is what we call the infrastructure or cloud view. This is based on who has the wires laid out, where are the computer centers, where are the clients, servers within the comm center, sort of the infrastructure perspective. And you see how we derive themes and areas from this perspective. Okay, so for example, the big project is deals with an aspect that you derive by thinking of the infrastructure. These comm centers with rented machines that you want to administer remotely and hopefully automatically, and that they perhaps grow and shrink the allocation of machines to your website over time, and so on and so forth. Right? The other perspective that we have is the workload perspective, or what's happening perspective. Right? We call that the e-commerce view. So in the e-commerce view, we like to observe the interactions between the actors, right? And if we move to, slide 4 has the pictorial view of the cloud. And if we just move to slide 5, we see customers that interact with businesses through the cloud, businesses that interact with customers and with themselves. We have marketplaces, which is where a bunch of businesses interact with each other in a tightly knit manner. We have meeting places, for lack of a better term, where many customers interact with each other. Think of instant messaging, or think of Nutella, right? So activities that are customer to customer oriented. Okay? Nutella is a system. It's way beyond that, but that's what John uses it for. Right. The fundamental essence is that you have client-to-client interactions. You can bypass any server, so you can add security, anonymity, and so on and so forth. It's the grassroots bottom-up revolution. I assume Big Brother will never track us like including software. And of course, written by 21-year-olds in their spare time. And I'm not kidding. I love these 21-year-olds, but they keep coming. So let me now go through a set of like 7-8 slides of what we think is doing Internet computing. So on slide 7, we have some overarching themes. We have observed that these end services that the sites want to provide are based on an ecology of interacting component services. It's many of them that provide these end services. It's not monolithic. It's very disaggregated. And by God, you want to outsource some of them by design. Okay? Typical but absolutely common examples, you want to hire out presenting the banners for the ads. Your ad management, you want to hire it out. Some people hire out all the search facilities. They renting them out to the e-commerce, the Altavistas of the world, right? And so on and so forth. And sometimes you collaborate, right? Because you can deliver this content and with help, say, of the Akamais of the world that are content deliverers per excellence. We're going to go back to this. But the net point is an end service is based on an ecology of interacting services. That is a big difference. Then we see that it's continual everything. It has to be up at all times. You want to deploy software fast. You want to deploy content fast and continuously, often, not just fast, but often, and so on. So it's like this thing never stops, and this thing never stops changing. This thing never stops being different. Okay? So again, very different than the old-fashioned traditional release cycle. Third point is that, in our opinion, the real end testing is impossible. Say you're huge. Well, you just cannot deploy another huge installation side by side with your normal site and simulate the worldwide workload that's hitting your huge installation. You just can't do it. So we're now being faced with a world where I need to deploy. I cannot mess up because I want to be continuously out there, and I cannot test really in the ultimate. So again, this is like different. These are overarching themes. We'll drill into them. Okay? A point that we wrote there, which is very important, is that errors cost you real money. You deploy this new content and you mess it up, that's bad, right? They may sue you. You deploy this little function that you thought was little and you go down, that's awful. There are lots of people that just say, don't go there, it's down, right? Errors can hit you here. It's not like the service pack approach where, it is a lot of money to fix errors, but you don't like lose your customer base, right? Here you may just lose the customer. Some sites have it changes. We have heard numbers up to $1 million a minute in lost revenues, not to count of these customers that then never come back.
So this is kind of a question about how much some of these issues are a function of a rapidly changing technology infrastructure versus sort of long-term implications. Like, for example, I think at some point there's going to be a big shakeout, and there aren't going to be 1,000 sites you can go to buy a book. You're going to go to Amazon, you go to Barnes & Noble, whatever. If Amazon's not up when I go to it, at that point, I may not have a choice. I may just have to go back, tomorrow. Or it's kind of like going to, I don't know, Kmart or something. So I guess my point here is, that these failures and errors, in a world where there's lots of competition, right, they're going to cost you a lot. As soon as there's not much competition, mistakes don't cost you a lot.
We don't think competition is disappearing, in spite of what the government may say. I've been filmed, I just remember that.
Just said it's a joke.
Oh yeah, jokes. No, we really feel that, sorry. We honest to God feel that competition won't be there. After Marvin says his point, I'll come back.
There's another thing, which is, if there's a bug in Office, when I sit there and I hit it and I'm using it, I lose maybe a little bit of weight. When a website goes down, because it's a centralized state, and there are people affected, even if they're forced to come back, the point is from the company, from the website owner's point of view, the cost of errors is now much more visible and much more significant because it's so centralized. And the point that this is going to eventually lead to is that the kinds of things you're willing to pay for to keep those errors from happening is going to be much higher. You're willing to buy a lot more hardware. You're willing to spend a lot more fancy software.
You're risking a lot. You're risking a lot more. And let me just add a second. Okay, it's much broader than that. Just hold back. It's much broader than that, which is good for us. Okay. Ben, to finish up this point, even if you're down to 3 people that sell books in the whole planet, remember you're clicking in the whole planet because then UPS or whoever else will deliver it to you, right? Whoever is beginning to be down a little bit more than the other one dies, and that's also when new will spring up. And just think of search engines. When I looked at this 2 months ago, I said, my God, look at all these people doing search, how they can all be there. Hey, since the new kid in town, Google, is just, displaced Inktomi out of Yahoo for personal data. Like, wow! Right? Wow! This is brand new. We're still thinking. This is really the marketplace and creativity in action, right? So I don't believe that on that side of the thread. And I fully agree with what Marvin said. It's also perspective. I have examples of people that actually do it the wrong way. I am agreeing with this. I'm agreeing that we better have good practices and their best practices and so on. But I hope that you'll see the need to still help them achieve some of these goals easier than what we do today. That's not true. And so it happens. And what you are trying to tell me is it better not happen often, or it should never happen. But yeah, like you know. Get to see how hard it eliminates the real work just suggested they should do a standard process. Just deploying one DLL on 4 machines is hard. Yeah. It just gets exacerbated. It gets exacerbated. We'll get to that. We'll get to that. We have examples. They're pervasive. Now there are several aspects, and hopefully through the slides you will see. But broad strokes right now, there is a pervasive need to deploy this, ideally without humongous staffs behind babysitting each installation, with respect to the 24/7 aspect of it. The other aspect that is new even in this scenario is the dynamicity of the work. Let's go to slide 8. We'll go. We are drilling in detail. So in that one and the next one, we will answer the question hopefully. Okay. If we don't, just hit me again. So under the theme new computing environment, we just mentioned the frequent deployment of new functionality and content. Okay. So just to contrast with that Chevron service, most likely here you have need to change where you are servicing more often. Okay. I know few examples with complete details, but MSN puts in 2 gigabytes of new content. And it needs to be done in a self-consistent manner and so on and so forth. So there's issues there. But it's frequent deployment. There is the aggregation of third-party services. I think the traditional world had the services, but they were more vertical, more in-house. Now we are coordinating with more third parties. Sometimes we lose complete control. Okay, that adds to the issues. Okay, so the issue of renting computers, the economic model has changed to a point where you pretty much can know that your load will not be constant over a year. Okay? And extreme examples would be like Olympics website. You know that the law is going to be this big while the Olympics are happening, and this little afterwards, and increasing to that. So how do you, if you want to leave that website forever, how do you manage this? Well, the web computer is a great solution because you call the Exodus of the world and you say, I need 100 machines for this month and 5,000 for these 3 months, right? And they just figure it out and they just wire you, all right? But then that creates many issues. Okay? Again, so sort of this, I like to view this as the accordion model of computing. You expand it, you shrink it. That changes, the elastic IT glass house. It's changing.
So, to what extent is worthwhile
Today is a real number, so they try to not do it, but that may go down over time. Okay, just as the difference between storing data and tape on disk is going down dramatically, right? So you're
something like that. So, the number of accounts that and whatever you put in there is this application slow down. But Moore's law is exponential. What other growth is also exponential.
predicting that by 2003, the microprocessors will talk to each other more among the humans. It's scary. The things they're going to say about us. We also observe that the computing in the internet is evolving towards servicing ever more difficult requests. It used to be static pages, ever more dynamic pages, and the computation to them is not hard. And there is the exacerbation of the traditional issues like security, large scale, geographic dispersion. The world hasn't changed its dimensions. It's just that the reach of one service now is the world. Well, it's never been like that before. So let's go to page 9, and a different angle here is the levels of choice for services. Okay? We really have the desire and the need to personalize all these interactions between the human or a business with the service. Yesterday, a couple of days ago, Butler was talking about the human machine and then the program to program, right? In either case, I think we're going to see a personalization. In the program to program, for example, you may have a complete dialogue to establish a quality of service. That's a degree of personalization, right? In the human to website, you have this, okay, what did he click, by when, how many times, right? So this makes challenging the offering of the service, and this is where tools come, okay, to help analyze, understand, improve that relationship. That's the aspect of detailed customer analysis. So this levels of choice creates new challenges. If you go to slide 10, there's a new scaling reality. It sounds big, but this planetary workload is a reality. You can get goods from anywhere. We're fairly connected, and we are keeping more and more connected. It's not slowing down for the next few years. They don't. They joke at monster.com. Monster.com is right now English-speaking world, a resume and jobs posting type of service. And they have 8.5 million people with accounts in it and 3.5 million resumes, and they post like, they had a couple of weeks ago like 350,000 active jobs listing at that moment. Okay? They work. This is not small. Saturday morning for 2 hours they saw it. Saturday morning, you know, they have less traffic, but they can never stop. High degree of variations in short time. That's something that it hits them very, very hard. Not only the load variations are going to be less in time than the time to live of a machine, like by a server, say up to 3 years, it's not, the load variations are very tremendous. But sometimes they're very seasonal. Just I mentioned Monster before. This is under the 8-week Monster. I have to understand that. The first 2 times that they're at on the Super Bowl, well, the Monday and Tuesday after the ad, their loads were 2x and 2.2x. Well, the very first time they were not ready. The second time they were ready. But just think, then it but then just think, how do you then mention it? You know, you've invested not only in the ad, but the people come, you want to give good service. You cannot say, you know, put your resume, but today it's going to take you 5 hours to do it. There is the extent of geographical reach that we touched before with respect to scale, and there's also the fact that we like this search ability, and hence we need to index what we need to search, and there's this increasing load of indexing the new things that are coming. So this creation of new content which is happening constantly everywhere, puts a pressure, continual pressure on the indexing infrastructure. Then in slide 11, we talk about new delivery needs. When you are delivering information, well, you want it fresh. And that's where all of the content delivery networks begin to help you. And you really don't want to see these high variations of latency. You want to all see it instant. You want to try and hide that. If you are French, you probably want to see everything in French. If you are, not to pick on and this localization, it's a really, really good. Right. There is also some needs, and this is not very good line here, on the client-to-client connectivity. This has to do, we have in mind here, chat, instant messaging. And together it goes this infrastructure for joint activities, which is broader. It's like what we're addressing with the Polar team here, the collaboration and so on, but we want to have more dynamic and and device characteristics that we talked about more than once. What is a bit more interesting and novel will require degrees of standardization is this harmonization between competing delivery systems. Marvin brought from a conference, a web caching conference in Lisbon, a great example of how these competing companies like the Akamais of the planet sometimes are both hired in because they specialize in different styles of content to help out a common customer. So the end service, as part of the processing, calls out to 2 of these content delivery networks for their parts of the job. Well, each one of them can do a great job and can do a fantastic job if they talk to each other. But today they're not quite talking to each other, so that we need to try and figure out how we talk to each other so that the combined effect is maximized. Because the paying customer just doesn't care who is providing it. Right? If you want just think that if you had been renting your hot water from a company and your cold water from another one, you just want the thing to work really nicely when you turn the faucets, right? Not when you just turn one, you get good quality of service, but if you turn two, you get it messed up, right? Well, there are different degrees where it's more often it's like the interference that they both draw on common pool resources. And if they're oblivious of the other's existence, the algorithms are not as friendly as if they know of each other's existence and they can say, all right, because of this type of request, you get 45% and I get 55% this time. Let's go at it this way. As opposed to both of them trying to get all. For example, this is a simplistic case, but that's one example. Do you remember more, Michael? With quality of service thrown in, though, that the traditional PP doesn't quite do. Well, so SQL Server and Exchange may go at memory in a meager manner and or disk bandwidth in a meager manner. So all of these are examples of resources that when you do not negotiate them are suboptimal. It's an extension of that. Right. Usually we will control the knobs. Yeah. But being where? Right? Mechanical source. And we don't have several pieces of such infrastructure in place. So it's not a matter of turning two knobs. We don't have the common way of expressing them.
If the whole environment was more finite, exactly what the issue was or how they implemented, so that problem was not completely solved and some problems existed. Would this be a fair way to characterize that because this particular environment is almost finite, this would be undoubted, so some of the problems which we are not solved are
Right. Well, they become more exacerbated. We are trying to express that with the exacerbation of traditional problems phrase. You're right on. Okay. But in addition, I think Marvin was saying, in some newer areas like content delivery, there's just pieces of the infrastructure that are not missing. You know, the 30 years of IP experience gave us mechanisms and knobs and so on, and in this case, they still haven't even done that.
So currently there's these transparent caches that some of the sources hijack the easy screen and send it off instead of back to the website to some cache, right? And if they're then cooperating set of caches, right? So sometimes that screen goes over to this cache, and sometimes it goes over to another. Get a web page, you're actually making multiple TCP streams. So you open one up to get, say, one of the images, and then open another, right? And there's some expectations when this network can come out and order which packets are going to come. These transparent caches violate that order because they have to route things to various different caches and they go around like this. So they may go open and replies correctly in the order that you expected. Some parts of the protocol to break them.
I challenge that because they don't provide new function every few days. There are aspects that are there. There are aspects that they are not. And we are not, I think we've come, Chris was saying, some of these are exacerbations of problems. Some of these are nuances as opposed to completely new computing. Okay. Great. No, that's good.
There's also those saying that if there's scale changes by another magnitude, qualitative, I just wanted to. And I think that if nothing else, the kinds of scale changes we see are different from the things that you ask. The number of people that are trying to do this and the number of resources that they're trying to put together. So there's things which they want us to put it up at the highlight this time. So it seems to me all this just qualitatively different. Even if individual components, you say, well, that's just like this is discovered in that one.
What's going on here is that out there on the internet, people have made certain assumptions about how things work. So there's a variety of protocols and a variety of related aspects of them. And people have after years said, okay, this is the way things work. They assumed that certain invariants are going to hold, right? Now you throw in something new like one of these overlay networks that turns out to violate one of these unwritten invariants. Unwritten in the sense that if you go read the TCP spec, or if you read the various specs, you wouldn't have said, oh, everybody has to obey certain things, right? And so with those unspecified parts, the parts that weren't necessary for the previous working of the internet, but we're implicitly, we've ended up depending on it. Somebody comes in and says we're going to throw in transparent caching, or we're going to throw in virtual private networks and so forth. They end up violating some of these assumptions. And the net result is we may know how to fix it if we could do a clean sheet, but the installed base of millions of routers currently does this, and somebody who's making money has come in and changed the world. And the problem is people are trying to figure out how to deal with that. Currently, the only way they have of dealing with it is they put the stuff in, they discover it doesn't work, and then they have to figure out what to do with it. They have no help, for example, with trying to figure out what interactions there might be between proposed new protocols and the old protocols. And they certainly have no help with trying to deal with installed base.
Okay, well, what I'm trying to hear is what should Microsoft be doing?
Okay. Hold back. I tried to explain that we had an introduction which we haven't finished, and let's move forward, okay? That's why you've confirmed what we've had, the experience we've had in all the other prior presentations, you know? So let's just talk, and we don't have much more to go. Yes?
One more about the slide.
Yes,
One of the
please.
things that you don't mention, I think, to make belong on the list is asynchronous delivery. By some sort of
That's
offline
true.
reliable messaging or by broadcast, and being able to use the client systems both online and offline, and having everything sort of make some sort of coherent sense when you do that.
Mm-hmm. That's a great point. I think it's an omission. Thank you, John. So let's talk about slide 12, and don't despair, there's only 13, and then we go to the next stage. Site management requirements, I think that changed. And just to keep banging on the old IBM mainframe thing, early in the year, for example, the sites now can be remote, okay, and very remote. Earlier in the year, I had the opportunity to visit some of our customers both in Argentina and in Chile. They happen to have their e-commerce sites in New Jersey. I mean, just think about it, right? It's all messed up for them in many dimensions. Like, okay, what's the locale of the servers? Will it be in Spanish so that the IT staff, which happens to live in Buenos Aires or in Santiago, is happy with it? Or should it be in English so that the Exodus of the World staff that happens to live in New Jersey are happy with it? All right, that, you know, these are problems that may not be earth-shaking, but they just make you think differently. Okay, and what are the tools that we should have and the system services that we should have to address this? Okay, so I think that has changed. You know, the remote IT staff and the frequent reconfiguration, and the others are lights out and continuous operation just gets harder, but they've been there. And on slide 13, the last one of this is just a pragmatic thing. We need to retool to new standards. And everybody takes the hit here, right? Because XML is there, it's not going away. WAP is there, it's not going away. HTTP SOAP is there, and it's not going away. And our software that was pre-standards, well, better, you know, evolve to these standards. And as these are probably not going to be the last ones, we probably will continue to need to move on. So the retooling to new standards is also a challenge. And how do we get to do that in a way that doesn't affect all the other conditions that we've been talking about, continuous operation and quality of service and service level agreements and so on. So then we've tried to think about some research themes.
Before
Yes.
you go on to the themes, so
Yes,
I'm trying to
Ben.
think a little bit about coverage here. And one of the things that seems like the question about what happens on the client side, sort of what the client model is in this space is not really considered in your slides, not a lot at least. So I was wondering, is that intentional, or maybe I'm misperceiving it? But you know, things like, you know, what's the model of connectivity? Are we assuming that the client's always connected? The client's, you know, got a laptop kind of thing where they become disconnected and then reconnected. Actually, you know, one of the things that Butler Lamson brought up the other day, which I thought was interesting, was that, you know, so Microsoft's, one of the spins on the .NET model is that you're trying to make the PC continue to be relevant in
Right.
this new world. Okay?
Right.
Now, almost everything you talked about so far is sort of, you know, IT workshops with tons of machines and staffs and things like that. So how do those things relate?
I think the client per se does not have slides. You're right. Part of our assumptions there are, we looked at this at the beginning, and we believe that while there's going to be an increasing amount of connectivity, we're never going to be constantly connected, right? But and that's pretty much what, you know, Butler was saying the other day. We believe in the same model. We believe that either the quality of the connection and or the availability will just not be there at all times, right? And also you may just want to be alone in the desert with being disconnected, period, you know, or inside an elevator.
I think that's a really good point. And the interesting thing, the way you describe people as viewing the problem is fundamentally server-centric.
Yeah.
As we talk about it, we talk about it up.
Yeah.
IT.
Yeah.
And yet, Microsoft as a company, and Butler's take, which I think is accurate, is we're much stronger on the client than we are on the server. And far more than the previous move to the enterprise, Microsoft.NET seems to be not focused so much on the server. So, I don't necessarily draw any conclusions from that, but it's an interesting observation.
No, but I think John, I'm not sure. I agree with what you said in the last statement. I think that definitely the move to Microsoft.NET is to not make the client be relevant. Because if you take just an IT view, then the machines just become a dumb terminal.
Right.
And .NET prevents the machines that are sitting on our desktop from being dumb terminals but being intelligent clients, so we can still sell a ton of software there. But that does not mean the servers go away. I mean, these problems still are there.
But could be also, based on what you just said, John, that maybe some of our weaknesses could be the server side, and that's what we're trying to address from that point of view. Because we've been so strong on the client side, and we're trying to address this issue, which is really what the development is going to is the server side. And I think that's why maybe the emphasis on that side.
And
Let me interpret this way. If the debate is where is the last level of cache? If the last level of cache is in, say, the computer that's at home, well, then you can tolerate errors between there and the server. Where you don't want to show errors is to the end user. So the last level of cache, your home machine can keep content perfectly accessed frequently. If the backend's down, it doesn't matter. It's trying to keep track of the stock price, the server's not working, it doesn't care, it will pick up later. If the last layer of cache is over the internet, then indeed, you're playing a very, very different game. So really, it's very important to understand exactly what we have as a vision for the future. Where
But I think it's,
where do we want it to be also?
That's right, where do we want it?
Right.
but I think it's a lot, it's, at least initially, the answer is going to be that it's in both of those places. If what I care about is browsing the web or doing some sort of, content delivery to me kind of thing, then caching that locally and, pushing it ahead of time is perfectly fine. Imagine now what I want to do is say order books online. Now, I could imagine, and the way it's right now is you talk to the server, and the server has to be involved. I can imagine an Amazon.com service that would let me do a lot of the stuff locally because the set of books I might buy is actually very small, so I can download all of those to me, and then I can choose to buy them at various times. I mean, but that's going to take a lot longer to build. In the meanwhile, it's going to involve network in real time.
Yeah, but you're a lot more tolerant because your front-end machine can say, the server in North America is down, but the one in Europe isn't. So I'll go and query then.
But in some instances also you get just one time hit. Basically the app will be downloaded to your machine, so the next time that computer can have it on your machine. It's not like every time you're getting the same program running.
I can take your order now, but they'll have to submit it in 30 minutes to start scanning.
I think you're absolutely right. The clients are really interesting and important part. The way I certainly have thought about the slides we've presented so far is this is our attempt at summarizing what we heard when we went out looking for them. Now, one of the reasons you don't hear about the client much when you go out looking is because in order to get maximum customer reach, they assume a minimum number of assumptions about clients. They use HTML 3.2. They don't use any of this other stuff because there's a million old browsers out there, right? So from the point of view of the services, the client is completely uninteresting because they can't afford to do anything more. Right. From our point of view, when we now go to the next section, which is research teams and so forth, we could ask, what can Microsoft do that has now 85% of the browser market? If we provided a different browser or different kind of things on the client, we can do all kinds of interesting things, including getting at some end-to-end things that will show up next. But what we've so far shown is what we hear when people say, this is the pain, this is the trouble, whether or not they're new or whether or not they know how to solve it.
There is a great homework line item, Ben, for us. We need to go put our ears into the client end of the spectrum.
Absolutely.
So far we've gone and put our ears into the e-commerce sites.
Well, and the other thing is that, the real leverage Microsoft has is that we do have a lot of control on the client. Yeah. And so to the extent that we
Oh, no, we have no control.
There's a lot of competition.
Yeah, the clients. Yeah.
So, I think,
as you said earlier, we only have
if we want to talk about the future, if you want to think about the future and what's possible, what are the interesting things going to be there? I think you have to definitely look at where that's going to be going.
And one of the things that this points out, though, is it's got to be compelling enough for the e-commerce sites who are currently willing to make minimal assumptions about client in order to broaden their reach.
Right.
There's always going to be some
Right.
people who aren't on the latest
And
platform.
it's
something which
you know,
gets them to change their
the
assumptions.
examples about the incompatibilities and the reach are really mind-numbing. So there are combinations of different releases of browsers and different releases of, let's me pick on NT 4.0 Service Pack 1 versus Service Pack 5 that just don't work. And the matrix that this e-commerce people have to have is like atrocious, right? And you always find one big customer that has 50 of these combinations of software that they want to be buddies with. So it's a big switch statement.
Here's a way to look at it that maybe, if we're lucky, the whole idea of NGWS is that the last 5 years have been an aberration. In that last 5 years, they concentrated on having big servers and they do all the presentation work, all the complicated everything, and dumb clients. They can sort of draw HTML if it's a good day. And don't always do frames the same way as each other, and whatever, that doesn't matter because all the logic is off of the server. We have, as things get more complicated, more and more customizable, it seems inevitable that's going to have to move off the client because it's hard to see sort of where you put all this customization for individuals and so on than there. And also they all got enormously fast processors that do something with them. One of the things you can imagine doing in order to extend reach is if our programming model, what ran on the client, could also run on the server if you had a stupid client. And so it could communicate just via HTML. Right. Maybe, right? And it would be kind of crufty, but you can still use links if that's what you really want.
You can do that with CodeLogix today when you can reside either on the server or on the client.
Yeah. This is just making all this work for the kinds of stuff people are deploying on the internet.
Well, this is making all this work. Right?
Yeah.
I have to object to the whole premise of that. I don't think it's a foregone conclusion that we're going to have a client-centric world or a server-centric world. In fact, I think it's hanging in the balance right now. And it really comes down to what we, Microsoft, do about it. If we don't take significant forward steps in having clients desirable, the desire will evaporate. They will just turn into terminals. That's what will happen. And the reason is because there will be no justification. People say, I don't need to buy a PC, terminal costly. If we make a compelling case for, hey, having local processing really buys you something and really helps, then I think that will be the dominant model. I think it hangs right in the balance today and it could go either way.
Right. And what it really boils down to is, can we deliver on the .NET plan?
Can we deliver on it? Can we deliver on useful functionality for why you want to machine your home?
And that's why we're going after the knowledge worker first, right? If you see the presentations are just so geared, building on our strengths. So I think we're in agreement there, and I think you found a nice gap into the homework that we've done so far. Go ahead, please.
And I don't know how this fits in. It may not fit in at all, but one of the issues that I think people that deal with the internet all the time deal with is the information overload. There's so much information, right? So this is all about technology to support tons of information, but it's not about any kind of technology to filter it or present it. To what extent should we care about this stuff? Do we care about this stuff? Is that part of the user experience? Is that sort of a different category of effort, or is it a system issue?
A lot of that goes to customization, doesn't it?
I think so.
That's where the layer is.
And
if I could add something to that, Tom, it doesn't know how it wants to. I really want to have it presented to me, and so it just gives me, a huge list of 500 books, and I get to go down the list and try to figure out what I want to do, as opposed to having a clever local agent that can do something else for me.
Aspects of that, which we think we care globally, I believe Microsoft should care, and aspects of that are under what we've been labeling search, okay? Because it's like search or filters or this, it's all, that's kind of your infrastructure to narrow it down.
Doesn't this come back to exactly the previous discussion? If we put functionality in the local processing unit that says, I will remove junk mail for you.
Right.
Just as there's a box now that removes advertisements from TV programs. This is a compelling argument. This is something that causes someone to go out and say, hey, I want one of these because I'm sick of seeing ads. If we don't do that, then in the end, the server guys win. You've just got to make a compelling case.
Yeah, I mean, I guess my point here is, in some sense, to understand how. I mean, at the end of this story, right? The real goal is to get to a really compelling user experience. That's all these scenarios, the .NET stuff. So part of the compelling user experience is that you don't have too much information flying at you that you don't want to see. So the question is, how far down into the architecture and therefore the tools does this particular end user goal drive us? And what do we have to assume about the way information is organized, or the way it's filtered, the way it's structured, and will that drive us to new tools? I mean, I don't know. I'm just sort of throwing this out and trying to understand whether or not this is in our realm of discussion or not. I mean, it's not something you spend much time talking about. So again, it's kind of an open question.
One thing we should probably mention is when we started on this, we observed to Dan Ling that this was a broad territory, and he said, okay, so skip user interfaces and all that stuff.
Right.
So this is almost by default. So I'm using this mostly to say, we realize this is not even an attempt at coverage.
Yeah, I understand that.
So there are lots of areas, information overload, information retrieval was one of those fuzzy areas where we intentionally sort of didn't spend a whole lot of time beyond saying, gee, this indexing, that kind of stuff clearly kind of fell into the systems end of things, and that relates to this new paradigm of associative retrieval. But we didn't look too much beyond that so far, even though it's clearly
and even as is, right, we've already seen that it's broad. Okay, so let's move on to slide 15, where we've split the research areas in themes. Okay, the first one is understanding dynamic sites, and this is a big theme. And in particular, all these tools to distinguish between normal operations and anomalous events appear to be very fundamental. And they all have to do with the 100 mainframes, but now it's 200, or worse yet, 700 smaller PCs that, they're as powerful as the mainframe. And the fact is that the common case, it's irrelevant, uninteresting. I don't even want to know about it. You really want to concentrate on what's going wrong right now. Okay, so like managing by exception or eventing by exception seems to be, presenting by exception seems to be the way we ought to move towards, which is not quite what we have today. You have today, you would like to, so the defragger tool, right, to just contrast, instead of showing me you have 20 volumes and let's see the defragging, it should say, everything is cool today, you need to defrag nothing. When you click on it, and all it takes is a little bit of programming, a little bit of analysis, and if certain parameters are met, you get your answer, right? Or it should say, gee, you better defrag that one volume of this 25,000, right? It's by exception.
Why? Why not just do it?
All right, you didn't like the example, or you didn't like the meta, or you didn't like the meta theme of going it by exception.
The whole thing is automatic. That's what you're
to
saying.
the extent we'd like it to be automatic. The things that can't be automatic,
Just defrag the disk.
so
Okay, I'm afraid you didn't answer my question to you. You didn't like my defrag example, or the theme that the example was an example. It wasn't the underlying theme of trying to manage by exception.
I'd say the example we gave was a case where it should have been done automatically, and that, in my opinion, almost everything should be done automatically when it can be. The whole point is we're moving towards no computer staff, as it says on the previous slide.
Right.
We want to run in the dark. Turn the lights out.
So to get there, though, we are far from there, unfortunately, right? And to get there, we need to have infrastructure, and we need to have system management software that will do it, and we need to have tools that tell us, well, whether things are happening or not.
I really think this is really what we're missing. I mean, the suggestion of the tool to be able to differentiate between an error, between loads set and everything. I mean, I was going to suggest something tomorrow, but I think with this tool and us taking the initiative of defining the format, because we are concerned with reliability and performance, etc.,
But else if I'm like an XML format or setter to support this processing, provided we do that, I think that's where we can make it. I think this is really an important aspect we're missing today.
This is the same thing which I think Butler was also alluding to, where there's an automatic sort of like some performance, whenever a component is not behaving with the intended performance, something kind of like gets flagged out.
Right.
I mean, if you walk into ITG today, if you go look at their site, which I did about a year ago.
Hold on. Let's have one meeting.
Yeah. I mean, we need to look beyond that. I mean, can we today run a program and know this is really an event or this is a bug, setting everything and so forth? We don't.
So, how do you know the normal cases?
Right.
Well, that's in fact,
That's the second point. That's the second point. Yeah, I think that's why this is a research. That's why it's a research subject, yeah.
Yeah, but I mean, if you're talking about building a tool that can distinguish the normal from the abnormal, then the sort of first question you have to answer is what's the difference?
Well, that's what I feel. More shaping has to be that
without that, you can't.
You take the common ground type. The common ground type probably plays against the study which ones are exceptions, which ones are not exceptions, etc. Everything. Imagine a tool that really understands this process. And it says, this is really an exception. This is a bug, etc., or some type of anomaly.
But then
they can describe. You have to describe it. It's not like something. I mean, the other approach would be a learning system that understands as things go on. It just understands.
I think the people with PhDs don't understand what's going on.
They normally don't understand what's going on, in my experience.
this is an area where, when we put these things out, especially since we're treading into areas where we're not experts, right? Felipe and I are systems and not tools people. We don't know if these are solvable problems. We're just saying, again, what we see is that, monitoring tools currently present you a bank of things that tell you everything's normal, and you got to sit there and go through 700 of them to see where the red light is. Yeah. And then, even if you solve that one and just sort of show me the exception and handle all of the automatic stuff you can and tell me this is the thing I have to act on, then you still get into the problem that every time I add a new factor to the system, a new service or a new something or other, it may break in ways I never thought of. And so what the normal case is something that we're discovering is getting ever harder to define. And it may be that it's an almost impossible problem to solve, but what we're seeing is that these larger systems are starting to get really painful to deal with because we don't even know what normal is.
And put another way, any progress we can proactively deploy in this area gives us such a leg up. Because not only Windows has this issue, everybody else also has the issue, right? And there aren't 700 mainframes on a given room, right? There are 700 Dell servers in many rooms, okay?
So we used to joke about that we need to improve the user interface. Someone said that we should use Microsoft Bob. And immediately there was a giggle and one guy said in the back of the room, he said, yes, I can see it right now. Bob starts, bands open, a little dialog pops up, and it says, how many hash buffers do you want in the database? And of course the answer is I don't even know
right.
Now we've got to get to none of this stuff. Everything that possibly can run itself has to.
We're not disagreeing with that. Yeah. Okay.
Sometimes a person's got to go in and replace the disk, right? And ideally, you'd like to tell that person to do it, right? It's not going to happen automatically.
The monitoring tools is the second order thing here. The first order is.
Oh, that's a different conversation. But this is a which I'm glad. Let's go have beer and talk about that. Delighted. But we've been trying to. So we have like 3 of these presentations, right? Now we're giving you our gospel about potential things for tools, right? Yes. We have one for databases, and we have another one for networks and systems. So let's move on to 16. Yeah, please, Ben.
So I think one of the things that is difficult, makes this problem even more difficult, is that you have this problem with capacity. You've got a certain number of resources allocated for problems, like X number of machines, and over time, presumably your load is going to increase. So you're not even in a steady state where one day everything's working fine, and then the next day all of a sudden you're doing exactly the same thing and it stopped working. Right? The reason it stopped working is because something's changing, and so it's not enough to basically say everything's fine. You actually have to say, Or people need to know, is it going to be fine in a week?
Bounds, exactly. Capacity, built-in capacity planning appears to me to be very important.
So it's not enough to just say, this is what's normal. It's actually you have to extrapolate something.
Any one of these, hold on a second, any one of these like established sites that it's like right there and they like to control their destiny a little bit better than others, have an order of machines like literally a trickle per week. They're putting machines per week into the comm center. And that's success, man, because they're doing more business per week, right?
I think one of the important things about, self-tuning stuff is great, but there's two problems. If I have a computer that has component A and has component B, and they're both self-tuning, then their self-tuning can get in the way of each other. That's the first order effect. Right. Secondly, so what you end up needing is some sort of central facility on that machine, and maybe across machines too, because all this stuff is happening in a larger network, that understands what these guys are trying to do and helps them tune themselves without, towards some common goal. It's also the case that the interactions between parts like A and B might be, when you have A and you have B, might have interactions that you have to tune for that neither the designers of A nor the designers of B could have known about, or at least did know about. And so you have to be able to add these things on in a fairly free-flowing fashion afterwards, maybe. And so it could be a big problem.
I think you come to the nub of the problem here. We write code in a way where we don't give a whistle about what other code on the system is doing. You don't look at most people's code and it is totally...
Yeah, but that comes right in 16.
Yeah. Step 1, check size of RAM. Step 2, allocate an array. Step 3.
Right. So let's look at 16 now. And 16 talks about this ecology of services, right? 16 tells us, let's try and have some profiling tools that, for example, can handle interactive system components in an end-to-end manner, okay? When you analyze, and we have a simplified path here, what it takes to serve a web page, you go like from IE5 to its proxy cache to a content delivery network DNS to the content delivery surrogate if it exists to an IP redirector, then to the IIS aspect that does the presentation logic, then to the middle tier, the IIS aspect that is doing the business logic, then probably to the third tier, the SQL server or the exchanges, backends of the world that have their data, right? This is a lot of components just to deliver one wimpy little page, right? This is like the mother of all string concatenations that you have here, right? And we have no tool to help them understand what's going on. So, for example, sometimes they look at the performance and they're happy to begin with. Then as the load goes up, they begin to see that, let me just speak on SQL Server, that it loads goes way up. Then they reflect and they say, what's going on? And by very difficult, cumbersome means, they figure out that, all of these fields, this static data that I put on blobs, well, darn, I put it in too many blobs. So instead of doing one retrieval, I'm doing 7. That's a huge difference, right? And hey, hindsight is 20/20 vision, right? We give them no way. We have no harmonious way of detecting how these pieces talk to each other, right?
So, in your experience, like visits sites there, one of the common things that I've heard from these guys, like there are these days when everything just sort of like came down on its knees, like the Microsoft.com thing, whatever. Anybody outside has how do these guys deal with these problems? They just use their
own custom logging infrastructure.
All right, so there are different elements to the answer here. What they absolutely adore the logging that all the components do. The right scribbling tidbits of information, right? The unfortunate thing is that there's no uniform way of analyzing this, so they have to look here, look here, look here. So that's another area where we could do a job for them, okay? And they kind of reverse engineer that. Now, what do they do in real time? For example, when they see that certain... okay, so let me give you an example in the search world. Inktomi, I heard this at Stanford lecture series, so it's kind of public. Inktomi delivers queries. Inktomi has a contract. You pay them per query, and they will deliver it to you in 200 milliseconds. They have the service level agreement. Now, they don't promise to deliver you the truth. They promise to deliver you an answer. Okay? So what they do is that when their load goes way up, they are beginning to not be able to deliver the best answer, they begin to deliver the answer I can deliver in 200 milliseconds. That's a way that they have. And by the way, when they see a query, you have many clauses, right? So they have a notion of a simple query and a more complicated query. When they see the complicated queries and they're overloaded, they don't even try to process them. They fail, period. They just don't answer, right? And because at that point it's pretty smart, I won't even think of that one. So that's an ad hoc way of them dealing with an overload situation. In other cases, my understanding is correct, they do analogous things by just basically choosing which HTTP requests out there they're gonna try, they begin to drop them at the outset.
I think this whole thing from the architecture, they sort of carry this through the whole system, right? I mean, if the machine fails, it just gives you back less information from the sites. It's really a nice observation. But I think this is sort of the key to actually building this kind of system, is the notion that the pieces have to be fault tolerant. And in the web, the piece that was fault tolerant was the user sitting on the browser. Right. And they were willing to hit the retry button or go to another site.
Right.
And that's why the whole thing sort of was glued together, but it worked. And it may be that this is really the notion that's going to be necessary to put the pieces together on this scale and on this many vendors.
There's an interesting thing, though, and Butler said this 2 days ago, and I think it's really, really important, right? The web succeeded because it presented web pages to fault-tolerant users, right? The trend on the web is to go to e-commerce, which is presenting web services to programs which are intolerant.
No, but my point is that the model which we've been working with may be the right one, is that we should be trying to build software that is much more fault-tolerant, because if you look at the software that really works on a large scale, it's things like TCP/IP, which has all of this retry mechanism built into it.
Right. I completely agree with fault tolerance. I guess what I was wanting to point out is the Inktomi model, you have to be real careful how much to read into it, because they have a very specialized thing they're delivering. It's these queries that are inexact search results, right? And it's okay if I give you any answer as long as it's kind of vaguely got what you want, right? If I purchase something or do a bank account transaction, it says, well, I probably transferred half. That's not going to work. And, so, an interesting challenge is as we go to these more exacting things on the web, we're going to have to, fault tolerance is going to be about the only thing that we have to stand on, because some of these other ad hoc techniques are simply not going to be acceptable when it's your bank account instead of a search query.
No, but it may be that your bank account transaction is going to be much more like, getting a TCP/IP packet there. You want it delivered once, and you want it delivered reliably, but underneath you, it may be sort of sending the thing back and forth and telling it, go do this, go do this.
Yes.
And it looks like, the guy hitting the retry button is a different level of abstraction.
Yeah, that's a very good point.
There's one analogy that just popped to mind is telephone systems, which have problems of overload because they can only handle something like 10% of all the phones actually trying to do a call at once, because they're just not engineered to do more. And so whenever there's an earthquake, it right next to the phone stops working. And there's a number of techniques that they've used that had to be developed over a long period of time. So just for example, you just start denying service to people. In fact, it's funny. It's not as though they enter a queue, and then the oldest people eventually, when they get into the queue, will handle them. They just you treat it as a stack. It turns out it actually works better with people, and the newer requests get service, and the older ones don't. And there's sociological reasons for that, but these systems get to be very complicated when you actually engineer them. When you call 911, you get placed onto a queue, unless you dial a special variant of 911, which gets placed at the head of the queue.
Oh yeah, what's that?
I'm not going to tell you. But I've never
the bold-faced 911.
I've never tried that, by the way, because I've never had the opportunity, and I'm not sure I would if it really were an emergency, because they would have changed it. But there's something I was wondering about. I've discussed this kind of thing with various people over the last few months. And one of the things they say is, oh, well, dealing with all these different network components, isn't that what network management software, like your Tivoli does from IBM or for Computer Associates or something, and, why don't we just, and so they must have solved the problem, and so why are we worrying about this? And I don't know anything about that software, and so I'm usually sort of shut down by that. Of course, the other person saying that probably doesn't know much about it either. We should not take too long on this detour, but there is documented evidence that some 70% of the people that try to deploy these big Tivoli-like installations fail to deploy it.
Meaning they buy it and then they don't use it.
Right, they buy it and they can't put it to use.
Yeah, I mean, they buy it for like $1 million and then they don't use it.
And they try real hard until they just totally fail and then they pull the plug.
So it's not the other 30%?
Honestly, I don't know.
Not even helping.
Or the other 30%.
Somebody's neck is on the line.
Right.
Or the other 30% is still trying.
Like that, we got this. I got this at a Lisa conference.
Right.
So I didn't have a chance to follow up on it. Basically, what the speaker was implying is this stuff doesn't really work, except in very small circumstances.
Or controlled environments. The big issue was the uncontrolled environment.
Right. Now, if you really pushed him on it, I don't know what he would really say in terms of how many people really got helped and so forth. This was somebody whose point of his talk was to say that stuff doesn't work, and here's enough, and we should all use PostScript. So
let's try and move to 17. Okay. So this is another theme that it hinges on the cost of messing up. So there is a very high cost for getting it right. Get it right the first time becomes ever more important. And it has to do with the fact that, as we mentioned before, we cannot test and we need to deploy things frequently, so it's just better try and get them right. So Marvin and I think that by now we can throw more resources and technologies and think out of the envelope and out of the box to get it right the first time, right? In particular, build technologies like, formal models and their checkers into the inter-service agreements or security, Just things that in the past have always consistently not gone right. Well, we may have a new opportunity here to deploy them because the cost of failing in your deployment is so much higher. So, if it used to take 3 minutes to compute this little squinky little verification of an invariant, and that was deemed absolutely irresponsible behavior for a developer, well, maybe it isn't so irresponsible now, right? So that's the point we're trying to make. Given that the cost of failure is so high, I think we have an opportunity to put more technologies to the cost of getting it right. Okay?
So I have a comment on this point, and we are already trying to address this problem, but the only thing that worries me here is that when you start doing things like this, a lot of things become undecidable. And so when you talk about programs and tracking, there are really very simple problems that are undecidable. So anything we do will have to involve approximate methods where you often simply say these two things cannot work together, even though they actually might be able to work together. And humans will be needed to work around those.
But let's just assume you're completely there. I'm with you, right? But the only point we're trying to say is that the, programming environment of tomorrow or the deployment environment of tomorrow could include tools that you would say, okay, I'm done programming my module. I'm now going to pass it through this verifier, and I'll come back tomorrow.
And the biggest bottleneck here is specification. So what we have to do is convince people to write interfaces or specifications of what they think their component is doing. That's the hardest thing. If you have that, you can do another thing.
I mean, one way of looking at what we're trying to say also is, in that, say 10 or 15 years ago, if you go to a systems person who builds low-level system stuff, performance is what they would say matters, right? You go to those same people now, and they're starting to say reliability, maintainability, availability is what matters. Performance is something I buy. Moore's Law buys it, gives it to me. So there's been a sea change in the attitude of some set of your customers, right? And if you had back pocket techniques that used to get rejected, Try pulling them out again. I don't know if there are any that you have, but there's this sea change.
I think there is this opportunity to pull rabbits from hats, right?
But on the other hand, IBM understood this a number of years ago, 370, they practiced it.
Yep.
And if you look at their market position today, we abjectly trounced them. So these sort of things are expensive. There's also time to market. Sometimes you can be first to market and not get it right first time, but you can still fix it fast enough that you're the winner. So this is one of those knife-edge decisions. And what you really want is you want to get it right, you want to get it right first time, and you want to be first to market. And I think these are self-contradictory goals.
So what you want to do is get it right enough so that you don't totally collapse until you get it right later.
So any tools,
want to win.
Anything that helps
any
us,
tools
that
you
help
provide us
you,
with
exactly.
Any of those would be interesting.
That's the whole point. It's not to get it perfect, but to get it better or better than everybody else, right?
This is why I mentioned specifications, because all these tools, even being undecidable, will only work if at some point somebody
Right.
is able to write down some specifications.
Yep.
Just ask you a question. I've assumed that, I've been saying something maybe wrong, and you can tell me, that if you have specifications, and there's some, but unfortunately, decided a lot of questions like that asked on the side of it, you could still imagine turning those into runtime checks, and getting some amount of value
Safety
from that.
properties, yes. If the liveness properties, no.
But okay, then you attack liveness by another technique.
Let me cut you off, guys, by limiting it as, hey, anything we can do to help get it right the first time, it's a good thing. Okay?
And one other thing that Butler said yesterday was instrumenting components. Being
Yes. Absolutely.
I'm curious where that would fit in, or where you see.
Well, we thought we had dealt with it 2 slides ago when we said,
Okay, that's what I wanted
Yeah.
clarification.
when we said that the prof, right,
You understand the dynamics,
yeah.
So this is a related comment. I'll make it really brief.
Now, this is great.
This is about the proving things about components or whatever. I think one of the things that needs to happen more is that the components need to carry around information about what has been proven about them. So to persist this analysis, one of the problems I think is that if you look at your traditional compiler, it does all this analysis, figures out optimizations or whatever, and then it just produces a binary and it's all gone. And so you see typed assembly language. I mean, there's various things that are sort of carrying this further. But I mean, in general, as a theme, I think we should really seriously look at the issue of everything that we do step to carries around permanently the information that we've generated, so that anybody else that comes along downstream can say, oh, well, what do you know about yourself, or what has somebody already proven about you? So I think that fits into that.
I think the whole, what you said earlier about, well, remember this point about Tivoli was from some guy who was pushing Perl scripts. Though people are saying this, I don't think their actions are necessarily consistent with get it right the first time. People are programming in an untyped language, turning off check it, because they're more productive.
It's exactly because they want to get it fast, you know?
So
There is a tension. So customers ask us, how can we apply OO goodness to the fast prototype goodness, you know?
Good, fast, cheap, pick any two.
Right. Ben, I think your theme is right on. Okay, and for example, if we're going to be dealing with a lot of XML-based blobs that you need to go understand, it will become a necessity to manage it and keep that info around, unless it becomes too inefficient. And to be candid.
And I think storage,
Right.
especially storage,
Yeah.
totally cheap.
So 18, the interaction among services, understanding them and managing this interaction between services, I think becomes paramount importance. Just remember our point that these are ecology of services. There are many services together presented doing this end service. So reasoning about these interactions, questions like, do I have a bottleneck, or do I have a service level agreement in force here end to end, or do I have a deadlock here? Any such questions are very important. Security is like a huge issue. It's getting harder, and this monitoring and enforcing security policies is really tough.
What is the FedEx tag?
A unique identifier. so that you know exactly where the data came from. And that's another area where, for example, a persistent infrastructure may help you, because you can put it around. A component may be lovely looking but may not tag things, and you may put your infrastructure just to tag. In that case, it may do many other things, right? 19, zipping right along here. Specifying and managing the evolution of services. We've been trying to make the point that we have to deploy function frequently. We visit some e-commerce sites that say, look, every week I put something that I consider important out there, important with respect to as a change, and maybe even daily I put little fixes that I don't even think about them, or I try to. Sometimes they have to scale back their frequency only because of the cumbersome of deploying a DLL to 500 machines. All right. In addition, I hinted before, we may have different changes of load over time, and not just growth. The example of the Olympics website, obviously has the drop too. So that goes like, not only you put more machines to the problem and less machines to the problem, but you would like to split a system because you want to partition it, and then you want to remerge it, and it feels like a B tree, but now it's for services, right? Do we do this? By hand and with a chainsaw, right? So everything needs to be harmoniously moved to this merging and splitting of services. And also part of this is the schema evolution and schema translation aspects of this. And for all of these purposes, to have any kind of infrastructure for simulation or for testbed, that's really needed. Okay. 20. There is this theme for Webflow programming, the support for Webflow programming. We mentioned before, where is my personalization going to be? So sometimes you go from the applets to the cookies on a client browser to the server and all the way back to the database. And how do we support the programming in this model? Well, now that we know that a code, an end-to-end function, will just go around all these components, what is it that we should put here?
One analogy, just the general, software development slides remind me of is that back in the 70s and 80s, people used to talk about the software crisis, and it was obvious that the cost of developing some piece of software was going up astronomically, and this was just not going to. Whereas this hardware was going down astronomically, and this is clearly wrong, and we're going to have a software crisis, and we're going to need to have better tools or better techniques or something. What happened was that there was no software crisis because of mass market software. And so even though Windows takes an incredible amount of money to develop, we could amortize that over a whole lot of customers. And so the cost per customer actually keeps on going down, and that's the great thing of mass market software. I think I wonder whether we're at the point where for these web services that people are currently developing, like at Amazon or so, the cost of these I imagine is going up exponentially. Because it's just there's just really hard development. All of these things are one-offs, and you're getting some amount of tools, but not about as much as they had back in the 70s and 80s. And so what can get us out of that is either that we start. It's more or less mass market software. Right? We have to sort of figure out that or making it much easier to develop the tools. Take your pick. And both of those are parts of NGWS. Right, and so maybe that's a nice analogy, or maybe not. I like it.
So let me go to 21 and talk about rapid development. Everybody likes RAD. And people, it's true. And people say, look, we wouldn't be in business. Some e-commerce come out and say, we wouldn't be in business if we hadn't been able to deploy this in 8 weeks or in 9 months, right? And this is wonderful. And then in the same sentence they say, but we wish we knew when we are about to fall off the abyss. In fact, we wish we knew before we are about to fall off the abyss. Because we deploy, yet with increasing loads, sometimes we don't scale. Right? And we don't want to have the emergency meeting, we're messed up, we don't scale. We want to plan for the rewrite. Invariably, they end up going from these scripted, fastly generated pieces of code to hand-coded C++, invariably. Now, they also understand that not everything needs to be redone for performance and or high availability. It's just like the 5, 8, 10% of it. So that's okay. But they just want to know as soon as stuff to do it, and they can size the efforts. They can manage the process. Otherwise, they're just surprised and in constant crisis. Okay? So we, again, thought that perhaps environments, well, to support this transition, that's very clearly something that would be super useful. But perhaps also environments that would constrain in how you do things will also help you, okay, in different ways. That's our naive take on that. Okay. Now on page 22, we have the theme of management of content. And this is a big challenge today for the large sites and even the small sites. The large sites, have a big mess replicating and partitioning the data about the instances of the services. And there are many services, right? IISs, SQLs, NTFSs. And in addition, you may have more than one comp center in more than one state and or more than one continent, for God's sake. Okay? So this has really gotten large. Preserving the referential integrity among linked pages. Well, this is, the old referential integrity problem kind of revisited. The web was great. At large, we lived and thrived without any guarantees of referential integrity. Click here. If not happy, click again. If it still fails, well, give up, click tomorrow, right? I mean, there is a lot to the web that was like that. But now, the other perspective is, again, I think the transformation into e-commerce. You go to a site, you really want to see coherent stories here. You don't want to be reading that Janet Reno is, dealing with Elian Gonzalez, and no, it's in Cuba already smoking cigars. You want to have it all consistent, right? And so it's important from the perspective of the deployers of service now to preserve this referential integrity that before, or for a while, we said, hey, we can live loose without it. Okay. Localization. This becomes an increasing problem for people that want to be global. And how shall we deal with it? Perhaps there would be tools that help us analyze the uses and then hence the way we should store it, right? Or, of course, the infrastructure may need to do this, but that's another big thing. Now, that's the end of my themes, right? So then Maria and I took the next step of absolute arrogance, intellectual arrogance, and decided to set some questions on the table that we think would be very useful to know the answers to, right? And that's what 24 and 25 have. And as I said at the beginning of the talk, we don't need to answer them. We would love to hear your responses to them. We would like to hear if you think that there are different questions that we should be asking about this area, but they're part of the exercise of, if we want to address the essence of what's happening now and will happen to us, maybe we want answers here. And I think we've heard today comments here in this room saying, if I had a better picture of the end goals, like, making my client vibrant type of goal, it'll help me define what I want to go after building, right? Some of these answers we think will help. Marvin, you want to add something to this?
Just there's two different kinds. There's the ones that we are sort of throwing out at the tools community, and then we've included the set of systems-oriented questions that we actually threw at the systems and networking group, just because you might be curious to know what the underlying infrastructure.
To be completely honest, a prior version of that slide was thrown at them. We've morphed it we've morphed two of the 4 questions.
That's right.
Okay, to be just truth in advertisement.
So by how, what do you mean by how anarchic is the internet content?
So, this is anarchism here. The underlying point is, would you want to assume that there will be centralized authorities where you can go and get the wisdom about how to transfer documents or get the wisdom about how to describe a light bulb, right? Or no? you will just have to deal with the French way of describing a light bulb. I keep picking on the French, I don't know why. And the British way of doing it, And that's what we mean. It has to do with underlying structure, organization, commonality, standards. Right?
In other words, how many players are going to be in any category? It's closely related to the second question where you say, okay, so there's all these standards being thrown out for a variety of things. How many of them are actually going to happen, and how many competing standards will there be, right? And so you could imagine a world in which we end up coming down to a relatively small set of standards and a relatively well-defined way of doing certain core things, sort of like the old days when you had the regulated telephone monopoly, right? There was one way to do data transfer. Or you can imagine that there'd be lots of competing ones, which would imply a whole different set of systems, infrastructure, things you have to do, a whole different set of tools you might need in order to deal with competing domains.
Why are you picking on standards as opposed to sort of particular technologies or particular pieces of software?
Just using it as an example.
Because in some sense, tools don't usually talk about standard tools. You're usually there to address a particular instance of technology. When you build a tool for somebody running on this type of processor, this operating system, this programming language.
So I actually think it matters a huge amount to think about how broad the reach of the tools are going to be. So, for example, if you actually think about building a tool that's going to support C++ programming, that is a lot, the fact that while there is a standard, nobody adheres to it. If you build a tool on top of TCP/IP, for example, you can rely on the fact that, actually this is a standard that people adhere to.
No, but the key thing there is not so much that there's a standard for C++ and whether there's a variant of it. The fact is that you've chosen C++. And that's what the first thing you've got to decide when you're doing the tool. And then at some point you start worrying about what the fringes look like, whether they're beyond C++ or whether there's a good description of what you need to do. But until you've chosen C++ instead of Java, instead of Visual Basic, your tool's going to look totally different.
So when I talk to people programming in the internet, in the web world, they're driving with the standard versus not, as opposed to, that's their fundamental reason for choosing a Java over a C++, that it is more standardized.
It's not that it's a better programming language?
No, it's a second order thing.
Unfortunately, I think he's right.
The other way to look at it is if you're looking at systems that are distributed end-to-end, you're looking at end-to-end dependently, then you're crossing many technology boundaries, right? So it's not like you say any piece is written in any language.
Yeah.
I mean,
think back to what he was saying.
No, but the language example wasn't the crucial one. And the crucial one was that we're talking more about sort of implementations of things rather than standards when we start talking about tools. We're talking about, is this language really what I want to build the tool for, and what kind of problems come up in this language? Or, if we have a collection of systems, how do they actually communicate? Is it really interesting that they communicate using a standardized protocol like TCP/IP, or is it more interesting that they talk, XML on top of this TCP/IP, or that they have their own sort of internal protocols and interactions?
We are using the word here in a very broad sense. We're really using it to try and denote any type of agreement among groups in any of the realms. And it's probably the wrong English word, or a standard is so loaded to, the IEEE 3.2 standard for this or that we may need something else. But in any realm where people are agreeing, we will label them that little standard.
Certainly in an anarchic world where there's competing things, I'm going to need ways of translating between them. So, for example, the mobile phone community is going with these WAP standards, which are in direct competition with the IP communication.
The mobile IP guys, right?
Well, just all the way.
Or Little Indian and Big Indian, right? Those two are standards, right?
So currently what we see is there's this battle, and there's all kinds of pain going on with translations between the WAP world, right? You have to write your web pages in HTML and in WML, which is the WAP markup language or whatever it's called. And so there's this whole cottage industry now going up of tools and other things just to deal with how do I make that crossing between those two boundaries? How do I know that a page is going to work in both, that I have an XML that's going to translate into both HTML and into WML? And, there's just all kinds of things like that. So I'm just wondering, is the world going to be a nice world, or am I going to have to deal with lots of things like that and the attendant implications?
Yeah.
And looking at XML, I think it's a fundamental question as to whether we're successful with things like this. So if you assume that there's well-defined schemas that people are agreeing on and communicating and architecting their systems based on that, you get one view of the world and one set of tools are useful. If you assume that XML is a neutral data format like that people can generate, and so you can read, but it has to be self-descriptive because there are no agreed upon schemas. You get another very different set of architectures that people are going to be doing, problems they're going to run into.
Right.
Now, I think this is one of the things that COM, for example, is fundamentally wrong, that OpenDoc took a very different approach on the standards and failed for other reasons. But OpenDoc had a standardized approach. If you're an OpenDoc, then you will do this, that, and the other. COM was much more benign, and it made things, the absence of standards was significant.
Right.
I think this is clearly about this. You go back to World War II. One of the things the Russians asked the Western powers after it was all finished was, how do you do the logistics? Because all we know is that every time we went to get the Germans, within half an hour they cleared off 250 yards, 50 miles down the road, set up again, and the moment we got there, they flew the hell out of us. And they did it again and again and again. And the reason is that it was organised anarchy. That at the one level, there's strict organisation. The tank commanders would say to their group of tanks, okay, we're all going this way, and they didn't care what the soldiers were doing. So the individual groups were well organised, but what individual groups did in relation to other organised groups just didn't matter. And I think that's what it's going to be here. It's going to be organised anarchy. It's going to be hard bits and soft bits, all mixed up together. It cannot be any other way. History's always shown that that's the most optimal mechanism.
There's another question about, anarchy, future anarchy, which is that it depends on what kinds of tools what kinds of systems we provide to people. Mm-hmm. The internet lowered the barrier to entry for a lot of businesses, mm-hmm. and we're now seeing that even so, there's economies of scale and so on, and people and there's not all that many booksellers on the web, big booksellers anyway. Mm-hmm. If we're successful in NGWS, it seems to me that will lower the barriers to entry again. Mm-hmm. And whereas I shop for books online only on Amazon.com. Because just keeping a history of me is good, and they do recommendations, and their presentation is good, and they actually have things well organized, and whatever. If it turned into a world where my local agent can sort of browse any bookstore and order the book from whatever, then in fact that's going to be quite a bit different. Those little bookstores will have more of a chance to thrive.
Right. And in fact, tongue-in-cheek, you should go to Barnes & Noble. They're all Microsoft on Windows 2000. But this. I was exactly right, because that's an agent, right?
Yeah, there's a huge.
I started using Amazon back when it used all digital software.
Yeah, if you go to Amazon, you're paying the highest price you can.
No, that's not true. I could walk down the street. I could walk down.
Anyway. No, but I think this is a great example of what the service.
Yes. Yeah, absolutely.
Yeah. Right. Yeah.
But the point is, if I could have a user interface that let me shop at Amazon.com and then I press the button to buy and it goes out to figure out where to buy the stuff, that would be great.
No, I have that.
I'm sure they would love to provide that.
There is a service.
The point about this segregation is that Amazon doesn't have to.
I've installed a client software that actually does that, and for the life of me, I cannot remember the name, but I will email it out.
Yes.
You please download it. Yeah. Amitabh, this is it.
Great.
With all 10 minutes to spare, only because I was rude and cut the questions.
No, you can.
We have 10 minutes discussion.
Yeah.
So feedback is welcome, including tomatoes.
And yes, and we appreciate already what we've gotten. This has been very helpful for us to help us strengthen hopefully we've given you, share some of the knowledge. Of course, when we write this paper, you will see more of why we're thinking the way we're thinking and what our biases are. I think, as Ben pointed out, there's a huge slant towards server-oriented things, which is true. It's like where we've been feeling, we've been listening there and we've been hearing there.
Well, one thing I think that would really help here would be a description of the issues of known technologies. Pull one of them out, one rabbit out of the hat. So, for instance, if you were discussing the TP monitors, this is a known technology. Where do they play? Well, they do load balancing, they can do redirection, they can do... But you're not saying, hey, it has to be a TP monitor, but you have to say, these are technologies that already cover some areas. Now, I would expect the technologies to be overlapping in some places, maybe even contradictory in other places.
Right.
But at least that would give you a sort of grouping to say, here are the problems, here are the problem areas, and look, here's some way that you can factor the problems, you can sort of shape them.
Right. And the other point you made before, I like this point too, the other point you made before about, is this like an exacerbated problem or a real new one? I heard you, we haven't split them like that. We haven't tried. It's easier to not try.
One other thing that was mentioned the other day was that the traditional notion of coverage is not going to be the same. And I was curious...
Of software coverage.
Right. I was curious when you're looking at research things, if any notion of that or any idea of where coverage is or what that will look like, if that's somewhere indicated somewhere, or if that's just something you're not going to address in this, what that really means.
Just think that from we haven't hit it. I think Felipe, personally think it's important,
I agree with that. Just curious what your thoughts are.
Yeah.
I think it's interesting.
Yeah.
So, I don't think people who are putting these sites together, are doing any coverage measurements or...
Yeah.
I don't think it's just...
Yeah, I don't have evidence, but I would go with Marvin's I don't have time type of answer, right?
But I saw some of these guys, they have almost duplicated hardware. They say that when they're upgrading, they have almost like a parallel set of hardware there. They set everything up and then they pull the switch.
That's the big switch approach, right?
They start developing on the other one.
No, they don't. No, they don't. They throw away the old hardware and buy new hardware.
That's also true. That's also true. So Inktomi, for example, does that. And one interesting tidbit, one of these all new half, the new was in a different building.
Oh, wow.
They were moving comm centers, literally. So the new was in a different building. And it's like, wow, and they pull it through, yeah. Was the service down? No. Did they notice something? Yeah, a little bit of performance for a while.
The other thing which I found that more and more people are doing is that they're developing tools which are kind of like very specific to their needs. And actually the speaker we have on next week, one of them from the that MSN search, when they have this thing which they call it something like the core technologies of Patrick Line, was the guy who found him. Basically, all he does is he just keeps building these special tools for the problems that they keep encountering. And that is an approach I've seen more and more people, like you're saying, like somebody, they log it or they have smart guys leading it, or somebody has these homegrown tools are sort of like...
This is really just sort of a throwback to the good old days of computers when I got started working. There were lots of homegrown solutions for things because there weren't very many solutions out there, and nobody sort of had generalized from particular instances. And at some point, that people started to see commonalities and come up with tools and share.
Exactly. That was the idea, to see how that's another perspective.
So building on what you just said, one of the metrics that we've started thinking about, we want to go out and ask other people, if you talk to others, you may want to do it too, the ratio of kludge code, sort of code that is part of a product, right? If you look at these sites, for example, these websites.
I don't like the kludge code. infrastructure code.
You look at these sites, and they have a SQL server and they have an IIS, and then in between there's this spaghetti wad of code,
Right.
That mediates between those, right? That spoon feeds the SQL server with batches and that caches the data because the SQL server can't take the load or because IIS has its own weird requirements. And so an interesting metric is how much of code of this,
and where?
let's call it glue code, is there and where is it? Right? Because those look like the areas, that's all the homegrown solutions where someday we ought to be able to offer them, a product.
So one of the crisper examples that I'm retaining these days is the ad technology in MSN. These people are now able or need to deliver 10 billion ads per day.
That's their goal. That's not what they do.
If you just divide, brute force, and it's like 115,000 per second, so they have this glue code to.
But this is something what WebForms is also doing, right?
Mm-hmm.
Some of the common code which everybody was sort of like writing in HTTP and it was being repeated everywhere.
Right.
They're providing a mechanism to like somebody can write it and automatically gets put in.
Great. How much differences do you see in good versus bad practices in this? I mean, how much of it is really a technology issue, and how much of it is a management issue?
There is definitely an education issue. There is definitely an education issue out there. People say, "Hey, your documentation is extensive," and by then you're saying, "Oh, here comes the next phrase, right?" And the next phrase is, "I don't even know where to go study what I have to study," right? And that's the downside of being extensively documented. So.
I think Macintosh broke new ground here. The best Macintosh apps, the manuals always remain in the clean mode. Never open them. Nobody's very good at that when we go get better.
That leads to another good game in the manual. No one wants to. That leads to another question. Are you getting any exposure that you've got any feelings for platform differences? Or the things that other platforms are doing better than we're doing?
Absolutely. The big example is scripts, right, and command language and so on. The Unix world has always been able to do everything from the command line, and headless and remotely, and yeah.
It's interesting that the rule of thumb we've heard is it takes 4 NT systems administrators to do what one Unix system administrator does.
Okay, so let's put it. Let me do it a little bit differently. Let me do it a little bit differently. But if you have 100 servers, and say you were to be able to have 1 operator in the Unix planet, you have 4 operators in the NT planet. Let me put it like that.
That's a better way of saying it.
And this is quantified. There are studies by Yahoo and others which.
That was 1 to 4, or 4 to 100.
No, the point was, the way I said
Microsoft
it,
helps
taken somewhat more
jobs.
derogatorily, and he was. Whatever.
It could be that NT administrators are brain dead.
Yes, right.
More characterizing problem.
Right.
We appear to be harder to administer than other platforms. Okay.
Anything that's GUI based.
That's right.
Yeah.
We
saw this. You can look at the IBM version of Unix. It's much harder to administer because all this sort of stuff is in the home GUI interfaces instead of the files.
Now, hold on.
Much more difficult.
But fortunately for us, this is not so bad. Let me turn it around. If you look at SQL Server, with its widgets and so on and so forth, it's a lot easier to deploy a nicely performing SQL Server-based DB implementation than the Oracle implementation. And so it goes both ways here, fortunately for us, right? But in the large,
no site has to go to deploy 100 copies of SQL.
Here's one of the key things I'd like to know about the number of administrators. I'll argue that I mean, not a lot of the Unix machines are actually bigger machines. That's why there's less administrators. And a lot of the screwing around that goes on Windows does is that people, there's no way that a single guy can administer a single NT machine and then have it replicate out to 100 others. And I would argue that 9 out of 10 operations that are done, the administrator did not need to visit the other 99 machines.
But is that true with like BSD-based web farms or Linux-based web farms? I mean, don't you have the characteristics much like the machines are comparable in power to the NT-based machines?
And
Some machines, you know, look at some.
But are we talking about some
any
machines?
machine or something like that?
We're not talking about some machines. A lot of them are Linux,
Right.
Linux boxes.
Right.
There's both. There's
Right.
low-end sites that run on, sort of Intel-based machines running BSD or Linux. A lot of the higher-end sites are exactly what Michael said. They run US10, they run E10,000 Solaris machines.
But they're not the ones who have 100 servers.
no, those levels.
Well,
But I would expect that
With 100 servers,
Right.
which does mean the small commodity-based hardware. That even in the commodity-based hardware world, that you're still getting this factor of 3 to 1.
But this is a major selling point for Sun, even against the other Unix machines. You put in an E10,000, and you have a single system image for 64.
That's right. And that's why NT Enterprise, that's why our Enterprise Edition is like, the big hope there.
Really hard to scale.
thanks a lot.
I find it to be one anecdote. We're talking about management content, trying to have referential integrity among everything. This just reminds me, and I'm sure you know, referential integrity comes at a high cost. It's just an anecdote. I could serve, one of the things we did in our Windows system was to try to have serialized systematics.